All right, chapter 4, or I guess unit 4, chapter or section 7 um, deals with something called completing the square to solve quadratics. So we're still dealing with quadratics. We're just going to be using something called completing the square now. So you'll notice that we've been over several different methods, and uh, and those different methods will pretty much help you solve quadratics, but there's certain situations to use them, um, and all of that. So let's start this off with a little, somewhat of a review, but it's almost expanding on some stuff we've already done. So, um, with solving a quadratic with square roots, when you have a perfect square trinomial, um, or a perfect square trinomial just means that your roots or your factors will look like x plus 7, x plus 7. They repeat. So it's like using the same number twice. So when I say perfect square trinomial, that's what I'm talking about. When you have that instance, you can actually solve the quadratic by square roots. So I'll show you what that looks like, because this will be pretty much how we solve, how we use completing the square. We use this with it. So let's look at number 1. And I don't think you'll struggle too much with this, so we're going to go over it quickly. So we've got x squared plus 14x plus 49 equals 4. If we are just looking at the left side, we can use the product sum rule to solve this. We've got 49. We need two numbers that give me positive 49. Multiply to give me 49. Add together to give me 14. That would be x plus 7. X plus 7 equals 4. So if you notice, when those repeat, we've got x plus 7 in parentheses, x plus 7 in parentheses. We can rewrite this as x plus 7 squared equals 4. So before I told you that we always needed x squared equals something with solving square roots. Sometimes you can get into situations where you have x plus 7, something in parentheses squared, is equal to 4, because now we can get rid of this exponent of 2 by taking the square root of both sides. So for what we were doing before, that's why I told you always get it x squared equals something for doing those problems. This is just a different variation of that problem, but it's the same concept. So if we take the square root of both of these, all we're doing on the left is eliminating this square, or this exponent of 2. So we'll be left with x plus 7. And you really don't have to put that in parentheses. So we'll be left with x plus 7 is equal to the square root of 4. Just remember, when we take out that square root of 4, it's still plus or minus 2. And now, to solve this, we need to get x by itself. So we're going to subtract 7 on both sides. And I'll show you what that looks like. It'll give us x is equal to plus or minus 2 minus 7. And all that means, to figure out what our two actual roots are, our answers are, solutions, all we have to do is split this up into two separate problems. So on one hand, we've got a positive 2 minus 7, and then we also have a negative 2 minus 7. So that would give me negative 5 and negative 9, so that's my two roots. So x is equal to negative 9 and negative 5. So that would be my answer. So really, it's the same concept as like solving a quadratic by square roots, except now instead of x squared is equal to something, you'll have like x plus 7 squared is equal to something. And it doesn't change anything for you, except it's just a little bit more work. So let's look at completing the square. So there's 6 steps to completing the square, and I try to give you these notes to help you so you can just follow these steps one by one to do each of these. So the first thing you're going to do is rewrite your equation ax squared plus bx equals c. So pretty much you want a squared and your x squared term and your x term on the same side, and then whatever's left is what you're going to have it equal to. And then for step 2, you'll just divide both sides by a, so that you're left with just a coefficient of 1 for your x squared term. And then you're going to complete the square, and that is you take b and divide it by 2, or half of b. So whatever that coefficient is, you'll divide it by 2 and then square it. Then you'll add it to both sides. So that's step 3. Step 4 is to just factor, which you're turning this into a perfect square trinomial. So you'll pretty much do what we just did in number 1. And then you'll take the square root of both sides. You'll create your two cases. One will be a positive value, a negative value, and then you'll just solve. So let's look at, we'll look at 2 examples. So let's look at number 3. So number 3, we've got x squared minus 18x plus 56. The first step is to take 56 and move it to the right side. So we'll actually be subtracting 56 because that's a positive 56 to both sides. So we'll be left with x squared minus 18x is equal to negative 56. Now that we have gotten to that point, we go to step 2, which is divide both sides by a. But if you notice, a in this equation is just 1. The coefficient of x squared is just 1. So we don't really have to do that step because dividing by 1 just gives us the same thing back. So let's look at step 3. So now we are on step 3, and that is to actually complete the square. And we do that by taking this b coefficient, or the x term coefficient, which is negative 18. And we're going to divide that by 2, which is negative 9. Then we will square that. So negative 9 squared would be 81. And the last step of that is to add it to both sides of the equation. So we will take, let me rewrite this. So we'll take this equation and we will add 81 to both sides. So if we rewrite this, we've got 8 squared, or x squared minus 18x plus 81. And that's going to be equal to 56 plus 81. So if we factor this left side by the product sum rule, we need two factors that multiply to give me 81, add together to give me negative 18. So it would be x minus 9 and x minus 9. And that will be equal to negative 56 plus 81, which is just 25. Now you'll notice that what we have in parentheses, those two factors, repeated. So we can rewrite this as x minus 9 squared is equal to 25. Now that we've gotten to x minus 9 squared equal to something, we can take the square root of both sides, and that will leave us with x minus 9 is equal to the square root of 25, which if we take that 25, it would be plus or minus 5. So essentially all we did, once we got to this point and we factored it out, all we did was do step 5, which was take the square root of both sides. So I don't think it's really hard, just the added step is taking this part of what we factored, which is x minus 9, and it repeats again, x minus 9, that perfect square trinomial. We just rewrite that entire thing squared so we can take the square root of both sides. And that leaves us with, it cancels out our exponent of 2. It leaves us with x minus 9 is equal to plus or minus 5. And then to solve this, we need to solve for x. So we would add 9 to both sides. So we'll end up having two cases. We'll have plus or minus 5 plus 9. So that's the same thing as saying a positive 5 plus 9 and a negative 5 plus 9. So you'll end up having two cases. One of our answers will be 14. One of our answers will be, 4? So x is going to be equal to 4 and 14. And make sure you pause the video and get all of this written down, because I'm gonna kind of start you off on number 4. But for the sake of trying to make these videos as short as possible, I may not work through the whole thing. We'll see. All right, so on number 4, if we want to do the same thing, we're going to complete the square to solve this. So we're going to rewrite our equation, which is already rewritten, so we don't have to do step 1. Step 1's already done for us. Now we need to divide both sides by a. So in this problem, a is 2. So you have to make sure that you go and divide each of these terms by 2. That will give us x squared minus 8x equals negative 15. Now we are to the complete the square portion of this, which I'll probably just solve this just so you have another example. So the complete the square portion of this means you're going to take b, which is negative 8, divided by 2, which will give you negative 4, and then square that. So that's going to give us 16. Now, once we've done that step, you're going to add it to both sides of the equation. And the equation it's talking about is this equation. Once we've divided by 2 and rewritten everything, that's the equation it's talking about. So we'll have x squared minus 8x plus 16. And then we'll also add 16 to the right side. Then we will factor the perfect square trinomial. So in this case, we can factor this by the product sum rule. So we've got 16. We need two numbers that multiply to give me 16, add together to give me negative 8. So we would have x minus 4 and x minus 4 equal to 1, because negative 15 plus 16 is 1. And now we can rewrite our left side as x minus 4 squared equal to 1. Take the square root of both of those. And I'm going to continue this down here. For whatever reason, it won't let me write. All right, so now that we have taken the square root of both sides, we're essentially canceling out this exponent of 2. So we'll be left with x minus 4 is equal to the square root of 1, but we have to make sure we add plus or minus 1. And then to finish this off, we're going to add 4 to both sides. So x will be equal to plus or minus 1 plus 4. So then that allows you to create two cases. So we'll have positive 1 plus 4, negative 1 plus 4, and those will be our two answers. So our answers will be 5 and 3. So x is equal to 3, 5, and that is your answer. So just make sure when you're completing the square, use these notes to help you, because that's why I make them. I make them for you to use. So if you follow each of these steps, I don't think you're going to have too much trouble. We'll work examples in class as well. And I think the more you practice it, the more it'll start making sense.